Okay, so today what we're going to look at is a bit more about what sine, cosine and tangent actually mean and where they come from. So I just want to give you a minute just to have a look at these triplets of triangles. So you're looking at the top three together and the bottom three together. And I just want you to think about what those triangles have in common. I'm going to give you 1 minute, and then in 1 minute I'm going to talk about that, but I just want you to think about your ideas first. So when this countdown timer gets to 0, I'm going to start speaking again. Okay, so what did you find? Well, hopefully you will have talked about how first, or it might not be the first thing you talked about, but hopefully you've talked about how all three triangles up here have an angle of 30 degrees, and all three triangles here have an angle of 60 degrees. That's one thing they have in common. The second thing they have in common is that they all have right angles, so they're all right angled triangles, and the ones at the bottom are as well, which means we can use the rules that we learnt about in our previous lessons this week, which are sine, cosine and tangent, and in these cases they're all going to be, the numbers you've been given are all going to link to sine, because we've got the hypotenuse and we've got the opposite, and if you remember SOHCAHTOA, then SO has the opposite and hypotenuse, that's a sine, and the bottom one has the hypotenuse and opposite as well, so they're all sine. Now what you may not have noticed, but hopefully you did, is that the ratios of the hypotenuse to the opposite on these, and the ratios the hypotenuse opposite on these, comparing the triplets of triangles, they are the same. So for example, here we've got at the top, here the top left, we've got 1 and 2. So if we do the opposite divided by the hypotenuse, oh, that's a bit of a thick line, hold on 1 second. If I do the opposite over hypotenuse, I get 1 over 2, a half. If I do on the second triangle along, I'll get 3 over 6, which also equals a half if I cancel down the fraction, if I simplify the fraction, sorry. And on the next one along, I get 50 over 100, which also simplifies down to a half, 1 over 2. The bottom one may have been more difficult to see, but what you get on the bottom, you have 0.866 divided by 1, which if we turn that into a more simple, a better fraction where you've got integers on top and bottom, that'll be 866 over 1,000. The next one along is 17.32 over 20, which also simplifies to 866 over 1,000. And the next one along, you'll also get 866 over 1,000. Now what this means in practice is that if the angle of a triangle stays the same, a right angled triangle, then the ratio of their sides will also stay the same. So if I have an angle of 30, then my sine operation, where we divide the opposite over hypotenuse, will always be half. If I have an angle of 60, then my sine operation will always give me 866 over 1,000, or 0.866. Now what this means is that we can use this knowledge, these ratios, to calculate unknown sides, like you've been doing in previous lessons, but you don't actually need to use a calculator for it if you know the ratios that the angle gives you. So here's an example, two triangles, one that I've got both sides for, one where I've got a missing side, and I'd like to use these two triangles. Can you work out what this missing value is? In your head, please don't talk about it for now. I'm going to give you 22 seconds to do that. And now when I say go, I'd like you to discuss with your partner how you knew that that was the missing value. Again, I'm going to give you 22 seconds. I'll give you 23. So hopefully what you discussed was that you know from this triangle here and from what we've just talked about that any right angled triangle that has an angle of 30, the sine of that angle, 30, will always equal 1/2. So sine, oh, did it again, 1 second. So sine of 30 will always equal 0.5 or 1/2, which is equal to opposite over hypotenuse, so in this case is 1/2. So I know that this ratio here should always also be 1/2 because this angle here is 30. So I've got to have this ratio here, so question mark over 80 must equal 0.5. So hopefully you were able to work out that this unknown side must equal 40 for that ratio to be 0.5. Now back when calculators didn't exist, what mathematicians did was they created a massive table of all the ratios for all the different angles for sine, cosine, which is there, and tangent. And this is what they use to calculate unknown sides and unknown angles for right-angled triangles. Now, you have devices now, calculators, that have all of these numbers stored in them, and that's what you're using, or what you have been using in the previous two lessons this week. And you can see that this is just a part of that book. So we've got degrees here, and we've got it going up in 0.1s. So we've got 24, 24.1, 24.2, 24.3, 24.4, and next to them the ratios for sine, which would be the ratio of the opposite over the hypotenuse, tangent, which would be the ratio for the opposite over the adjacent, and cosine, which would be the ratio for the adjacent over the hypotenuse. And if we move across here, you'll see that we've got a bit where we've got the degrees equals 30, and as you can see, sine 30 in this book is it gives you the ratio of 0.5, or actually they calculated them to 4 decimal places, so it's exactly 0.5, so 0.5000. So the way they did this is essentially they drew triangles with different angles, measured the sides, and therefore got the ratio from those sides, and created this big table with all different values, which meant they could then use that to work out unknown values when they needed to. As I said, you now have a device, fits in the palm of your hand, that has this whole thing programmed into it, so you can find out the ratios at a touch of a button. So, on to our aims for the day. What I'd like you to be able to do by the end of this lesson, and so I'll check that this has gone in on tomorrow, on Friday. I'd like you to be able to, firstly, there are certain values of sine, cosine, tangent, certain ratios, if you like, that you have to be able to recall. And those ratios are for when the angle of the triangle is 0, which sounds a bit weird, but you can have that. So an angle of 0, an angle of 30, 45, 60 and 90. So those are the ones you have to learn, and there is actually quite a neat way of remembering those, which I'll talk about a little bit later. And you also need to recognise the shape of graphs of those value of sine, cosine and tangent. So as the angle changes, how does the ratio change? And you need to be able to recognise the graphs and be able to sketch them as well if needed. So we're going to start with the graphs today. Okay, so you're going to plot 3 graphs, but all 3 graphs are going to have similar axes. You could technically plot all 3 on the same axes, but I think it would get a bit messy if you did. So the axes that you need are going to be all the way across and up and down, and it's going to go to -1 and 1, and I want you to go from -360 to 360, and you need to go in all in intervals of 20. So you're going to have -360, -340, -320, -300, and so on. And then going up, you have 20, 40, 60, 80, 100, and so on. And then you probably want to go up in 0.2s up and down, so you have -0.2, -0.4, -0.6, -0.8, and up 0.2, 0.4, 0.6, and 0.8. So just to recap, you're going to have -360 to 360 going across. You're going to have 1 and -1 on your y-axis, and you're going to go up in 20s on x-axis, and that's where you're going to plot your points, and you're going to go up in 0.2s on y-axis. And I'm going to give Miss some time to hand out the graph paper, so it's going to give Miss a bit of time, and then I'm going to start the timer. You've got 15 minutes to draw those graphs. It shouldn't take you that long, but if you don't take quite as long, Miss has an extension test for you as well, just to practice some calculations of angles and sides from the last 2 lessons. So in 50 minutes, I'll come back and we'll talk about the values that you have to know for your exams at the end of year 11. Okay, graph paper all handed out, and you'll also need rulers and pencils. Ideally, make sure you draw graphs in pencils. So your 15 minutes starts now. Make sure you ask Miss for the extension if you finish your 3 separate graphs. 1 of sine, 1 of cosine, and 1 of tangent. So you're going to be typing in into your calculator first of, for example, -360, and you're going to press sine. And if you do that, you get a value of 0, so you'll plot it here. And then you'll do the same for -340. So put -340 into the calculator, hit sine, you'll get 0.34. So you're going to plot it here. And then -320 into your calculator, press sine, and you get 0.64, and you plot it here, and so on until you've done all the way across. And then you do that for cosine, and you do that for tangent, and ready to discuss for Friday's lesson. So I'll start the timer now. Okay, time's up. You should have a little bit more time after the next bit to finish those. But I just want to quickly talk about now the values you need to know from that graph. So as I said, you have to know the values for sine, cosine and tangent for these angles. So essentially the ratios we've been talking about this lesson. So that's 0, 30, 45, 60 and 90. And if you finished your graphs, you'll see that actually the values for these go up and down. It's a cyclical graph. And so if you know these values, you'll also be able to work out other values, which we'll talk about in a later lesson. So if we just look at these values, and you might be able to see them from your graph, there's the values for 0, the values for 30, the values for 45, the values for 60, and the values for 90. Now, first off, let's just quickly talk about this one here, the NA. So tangent doesn't have a value for 90 degrees. I just want to quickly talk about why that is. So if we draw a triangle, a right-angled one, there's a right-angled triangle, and this angle here, let's say, is 60. Now, if I did an angle of 90, this is what the triangle would look like. So that's 90, and technically that's the hypotenuse, that's the opposite, and that's the adjacent. Now, if we think about what the length of this line is, the opposite, well, this is never going to meet the hypotenuse because they're parallel to each other essentially, because these two angles are 90. So if this opposite value goes on forever, then essentially that value is infinite. And so what we'll get is tan of 90 equals opposite over adjacent, which equals infinite over whatever value a is. And it doesn't matter what value a is, this will always equal infinite if you like. And so infinite isn't a number, and therefore we don't get a value. You'll probably have noticed that your graph for tangent will it'll go steeply up to 90, but it'll never actually touch 90. There's not a value for it. So that is a weird result that can be explained as like that. Now the other numbers you'll notice are a bit strange. Now these are very difficult to commit to memory. So you've got 0.866, 0.577, 0.707, 0.866. But you'll see they do repeat. And there is a way of remembering these. And the way of remembering them is using surds, because these values are actually root numbers divided by another number. I'm going to talk about what that means on the next slide. So on this slide, I'm going to try and show you how you can remember these. So just fill in a couple of these that aren't there. So cosine of 0 is 1, and sine of 90 is also 1. Now the other values are all going to be something over 2. Okay, so they're all going to be something over 2. For sine and cosine, tangent is a bit different. And they're all going to be the root of something over 2. And the values you get are actually, for sine, root 1 over 2. For 45, root 2 over 2. For 60, root 3 over 2. And if you want to continue that trend, you can see that it's going up root 1, root 2, root 3. Actually, 1 is the same as root 4 over 2, because root 4 equals 2, 2 over 2 equals 1. And you can go backwards, so root 0 over 2 will also equal 0. And then for cosine, the trend goes backwards, so you're going to have root 4 over 2, root 3 over 2, root 2 over 2, root 1 over 2, which is, remember, root 1 is 1, so this one and this one are actually just 1 over 2. But you can use this to help you remember all of them. And then 0, as we put at the top, for sine is root 0 over 2. So you can see that you can use this notation, the surds, to remember sine and cosine. If you know which angles you have to remember, and then you can simply use this pattern to help you remember sine and cosine. Now for tangent, you get for 30 degrees root change back to the pen, root 3 over 3, and for 60 degrees you just get root 3. So those ones perhaps you'll just need to remember. I can't see a pattern there forming. So what I suggest you do is copy that into your book so you've got those values to hand, and then complete the graphs if you haven't completed them already. And then if you have completed the graphs, then Miss can give you the extension work that I provided where you're practicing working out sides and angles, linked to also working out compound shapes. So I'm going to leave that to you, and I'll see you tomorrow where we can just chat this through if there's anything that you haven't understood.